Hi! In this video, I'm going to go over 3 exponent rules that I reviewed in another video, and then I'm going to explain 2 more. So in another video, I reviewed 3 exponent rules. And we have the title of each rule, or the name of each rule, in black. So the first one was the product of powers, which means that we're multiplying 2 powers together, and these powers have the same base. So then in purple, I have an example. Like, for example, if we had 6 to the exponent 3 times 6 to the exponent 4, then it comes out to be 6 to the exponent 7. So this means that if we're multiplying 2 powers with the same base, we can just add the exponents. The second rule I reviewed was the quotient of powers rule, where we saw if we're dividing 2 powers that have the same base, it turns out that we can just subtract the exponents. And then a power of a power means that if you have a power, so a base to an exponent, and then all of that is raised to another exponent, it turns out, like in this example, that we can just multiply the exponents together. So now I want to look at 2 more rules. The first is the power of a product rule, and then the second one is really similar. It's the power of a quotient. So what I mean by a power of a product is, suppose we were multiplying 2 things, like maybe a times b, and we were raising them to some power, like to the exponent of n. So for example, let's look at an example. I'll make it in purple here. Say we had x times y to the exponent 3. How could we simplify that? Well, what that would be x, y times x, y times x, y. Now we know when we're multiplying that we can multiply things in any order, so I'm going to regroup those and put all my x's together. I have 3 of them, and then I'll put my y's together. So I've got 3 x's, multiplying 3 x's, so that's x cubed, and then same thing for y, y cubed. So what we see here is that we can sort of apply this exponent to both of the products in what we're multiplying down here. So the rule is going to be that ab to the exponent n is equal to a to the exponent n times b to the exponent n. So the power of a quotient, that's going to be really similar, except instead of multiplying our 2 things, we're going to be dividing them. So it might look like a divided by b to the exponent n. What does that equal? So say I'll do an example again in purple down here. Say I had x divided by y. Let's do it to the exponent 3 again. That's equal to x over y times x over y times x over y. And the way we multiply fractions is we just multiply the tops. So it's x times x times x, which I'm just going to write right away as x cubed, divided by, and we all multiply the tops and multiply the bottoms, or multiply the numerators, multiply the denominators. So that's going to be y times y times y, which is y cubed. So our rule is going to be that a over b to the exponent n is equal to a to the n over b to the n. So basically what this tells us, if we have a bunch of terms that we're multiplying and dividing together, these 2 rules together, tell us, and if we're raising all of that to an exponent, for example an exponent n, we can just apply that exponent n to every term in the product or in the quotient. So it's kind of exactly what we'd hope that the rule would be. Okay, so we've got 5 exponent rules altogether. You should have them all in a handy list so that you can use them to do some simplification exercises. And in your list you should have what I've got in green with the yellow box, what the rule is, And you should also have the name of the rule. And all these names make sense. Power of a product, that means multiplication. And we have got a power of that, like this. Power of a quotient, that means division. And we've got a power of a quotient, which means we're raising it to an exponent, and so on. So make sure you've got a handy list with both the names of all 5 rules and what the rule is. Okay, good luck.